Let's take a look at the chain rule. So when do you use the chain rule derivative? Whenever you have a function inside of another function, that's when you use the chain rule. Let me give you some examples to show you what I mean by inside functions. So here we have the sine of 2x, and what we would say is that the 2x is inside of the sine function. So the sine function would be the outside function, the 2x would be the inside function. We can also have something like the cosine of x squared, where the x squared would be the inside function, the cosine would be the outside function. Other typical examples, e to the 5x. 5x would be the inside function, and e to some power would be the outside function. Another example, e to the x squared. Once again, e to some function is the outside function, x squared is the inside function. We can also have something like the ln of 2x, where 2x would be the inside function, the ln of something is the outside function. Or something like ln of x squared or any other power. So x squared is the inside function, ln of something is the outside function. So how would we take the derivatives of these functions? You would take the derivative of the outside function and multiply it with the derivative of the inside function. So let's go ahead and take the derivative of all these functions that I showed you. So the derivative of sine of 2x, like I said, take the derivative of the outside function, multiply it with the derivative of the inside function. So the derivative of the outside function, which is sine, would be cosine of 2x. So at this point you don't touch the inside function, just the outside function. That's why cosine of 2x times the derivative of the inside function. So that will give us the final result of cosine of 2x times 2. Let's do the cosine of x squared. So the derivative of the outside, the derivative of cosine is negative sine. Don't touch the inside function. Times the derivative of the inside function. So now before moving on to the other four examples, let me give you one more example that I just thought about that involves trigonometric functions. Let's say you have something like the sine of x to the power of 3. So in this case, our inside function would be sine. Our outside function would be to the power of. So let's go ahead and do this example. So the derivative of the outside, if you remember this rule, so now we're going to apply the same rule. In other words, we are treating sine as if it were x. So the derivative of the outside without touching the inside at first, times the derivative of the inside. So that is another common example you might encounter. Let's go ahead and do the other four examples. So the derivative of the outside will be e to some power. And if you recall, the derivative of e to the x is simply e to the x. But in this case, the inside function is 5x, so times the derivative of the inside. Let's move on to e to the x squared. So the derivative of the outside, in this case, as we remember from the previous example, stays the same since the derivative of e to the x is e to the x, and times the derivative of the inside function, which is 2x. So now let's do the LNs. So if you remember, the derivative of ln of x is 1 over x. In this case, it would be 1 over 2x, that's the derivative of the outside, times the derivative of the inside. Since this is 2. And lastly, the derivative of ln of x squared. So the derivative of the outside times the derivative of the inside, since this is 2x. So that is my answer. And let's go ahead and take a look at one more advanced example where you might have not just 2 but 3 functions. Let's go back to this sine of x to the power of 3 function. Let's say that instead we had something like sine of x squared to the power of 3. So now you can see that that our outermost function is to the power of 3. Then the one following that, the one inside of that one, is the sine function, and inside of sine function we have x squared. So let's see how we would handle this. So we would handle this in sort of layers. So the derivative of the outside times the derivative of the inside So the derivative of sine of x squared, we do the derivative of the outside times the derivative of the inside. So that's it for this video. If you have any more problems that you don't understand, just post them in the comments below, and I'll try to answer a few of them.